Alright, my friend, we are ready to tackle another chapter of this B scene. We have this time to make a lot of exercises regarding strings. As you can see, we have a string copy, string is alpha, string is numeric, lowercase, uppercase. Basically, for this chapter, you have to understand in the marrow of your bones what strings are. That's why this is gonna be just a preliminary video. I want to explain to you exactly the parts that I didn't quite understand about strings, okay? Maybe the things I'm gonna tell you are kind of obvious, but it's better to be redundant on the things that I want to explain. Everyone should be able to understand what is going on with the following exercise. So if you totally understand array strings and pointer strings, well, you can just skip this video. If on the contrary you think that you have some weak points regarding this argument, just stick with me. Let's watch together this code. As usual, I have included my standard input-output to use the printf function. Inside my main, I have declared a string, an array string with the content value of hello. Then, very simply, I'm gonna print this string with the printf function, and then I'm gonna change the char in position 2 of my array with the char k. Okay, this is a legal instruction, right? I can modify the things which are inside my array. And then, very stupidly, I'm gonna print another time the allegedly changed string. Okay, let's run and let's see if the program is gonna work accordingly, okay? Okay, compiled, and then I'm just gonna run this very easy program. As you can very clearly see, I have the char in position 2 that has changed to a k. Perfect. Easy vanilla program for you. Now, let's do something different. I'm gonna change my array string with a pointer string. Is this program still valuable? Is this legal? Can I indeed change the char in position 2 with the k using a pointer string? What do you think? Let's try to run this program. So again, I'm gonna compile and then I'm gonna run. You see, we have a mistake here. We have sig bus error. Never mind, it's a mistake. If you want to go deeper into the details of this, just search for sig bus, but it is not important. You have a mistake. You cannot change a pointer string. You may wonder why it is the case, what is happening beneath the surface that I don't understand. So now we are gonna investigate this point very well. We are gonna have a very good comprehension of what is going on with this strings affair. As usual, we start from the first principles. So we watch what is inside the machine and we analyze step by step what is going on. This is the real way by which we can understand stuff. So we have a RAM. We have a RAM, which is a chip made up of transistors. This image for me as a programmer is totally useless because I don't understand how I can use these silicon chips. So I need to raise the level of abstraction. We have to go a little deeper. Going a little deeper, I can immediately abstract these chips as a series of bytes. Basically, I can abstract the RAM as a very long array, right? That's a very good abstraction for understanding and using, therefore, these chips, all right, as a programmer. Basically, this is the view that I have as a programmer of my silicon chip. A series of bytes, every byte is composed by 8 bits. Every bit can be turned on and off, and every byte represents something, a char or a number or everything that I decide, right? Furthermore, every byte has a specific address, which is in hexadecimal. So with this level of abstraction, now I can understand thoroughly what is a RAM and I can use it, right? It is very easy. A series of bytes, every byte is composed by 8 bits, every byte is addressable, period. That's my RAM. Now, every time you launch a program, namely when you do a.out and you launch your program that has been compiled, what is going to happen is that the operating system is going to create a memory frame. It is the layout of a process. A process is just a fancy name for a program which is on the process. It is ongoing, right? So when you launch your compiled binary a.out, you have this process which is running inside a specific space in the RAM. With this slide, I have created a very easy and intelligible sketch about this layout of a process, just for you to understand what is going on. Of course, this is a model, this is a simplification of reality, but it has all the bits the important parts that you need to understand. So I have my program. I'm going to launch it in my terminal. And the operating system is going to say, whoa, 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 what you want to do? You want to use the RAM to make your stuff? Are you crazy? Let me do the thing. I'm going to create to you an ad hoc place with all the blocks in which you can put your stuff. Let me do the work, okay? And I say, okay, operating system, do your thing. Just allocate me a space where I can do my stuff and give me back the addresses, the position. So the operating system does its work and gives me back a space in the RAM. So I have a place which is the stack that you perfectly know by now, right? The stack is where the action lies, right? When you call the main function, you get spaces which are inside the stack. Then you have another range which is called the heap. Here lies the memory allocated with the malloc function. You will see later what I'm talking about. Don't worry if you don't understand what is an heap now, it is not important. Then you have another space which is called data. Essentially here you have data related to your program, like for example global variables, but this is not the point now. I don't want you now to understand to the finest detail what is going on inside these slots. The really important part is the overall principle that you will very soon understand. By the way, I will link you some videos if you want to further understand what is going on with this layout of a process. So we were at the data slot where you have global variables and other stuff. And then you have the text slot. Basically, you have the binary of your program, of your code, which lies inside this slot. Text is the code. The text is the code. So long story short, you have a slot which is called text, in which lies the code. A slot named data, in which you have, of course, data like global variables. And then you have the stack, where all the action takes place. If you're confused, again, this is a very, very shallow explanation. Search for yourself if you want the details and if you want to understand really what is going on. But for our purpose, this is perfect. So what's the point of this memory layout and with the strings? Let's make a very simple program. I have here a main function in which I declare a pointer string, hello, and an array string, world. You see, in my stack, I have my main function, which is the Tinder function of all the program. As you can see, my pointer string points somewhere. By now, we don't know where, but we are gonna very soon find out. On the contrary, my array string lies directly inside my main function, right? I have an array structure with all the charts inside. Very simple. So where the fuck is my hello, my pointer string hello? If we zoom out a little bit from the stack, we see something peculiar. Here I have all the layout of my process, and I see that my pointer goes directly in a zone called text. Indeed, where my code lies, right? And here we have the most important point of this video. You see, in my stack, I have a read-write place, read-write block. So my operating system has prepared these slots with specific permissions. To be specific, in my stack, I can read and write stuff. Namely, I can read and write inside my array string, right? Because it is inside the stack. So I have the permission to change stuff that is inside this slot. On the contrary, my hello is in a slot in memory which is read only, right? I don't have the permission to touch stuff which is stored inside this place. Is this confusing? Well, my suggestion is that you don't have to lose yourself into details. Only keep in mind this principle. When I have string literals, they go in a place which is read only, okay? Period. I cannot change strings which are in read only memory. My array string is a quote-unquote fake string. It is just a series of charts inside a data structure inside an array, right? Okay, this is the framework by which we're gonna analyze the programs that I'm gonna show you very soon. So look at this. We have another program here. This time I'm gonna declare a pointer string, hello, and an array string, world. Then I wanna know where is the string literal stored. So I'm gonna just write the pointer itself, right? Then I say, where is the pointer itself? So the pointer pointing to the string literal. And then I'm gonna print the address of my array, right? Then I'm gonna do something strange here that I will explain immediately. Let's just run the code. Compile and run. You see here we have the addresses of my strings. I have my hello literal, which is in this address. Then I have the pointer pointing to this string literal, which is in this address. And then I have my array, which is in this address. As you can immediately see, these two addresses are very, very close. And you can already understand that these two addresses are in the same place. And as you previously saw, this is the address of the stack. Then I have my literal hello, which is in this very different address. It is very far from here, right? Let's dive a little deeper, okay? So this time I'm gonna do something which maybe you don't know, but it is an opportunity to learn something new maybe, okay? With this ampersand, I'm gonna launch the process add.out in the background, so I can do other stuff with my terminal. Okay, launched. Then I'm gonna do this command, which is ps, that is gonna show me the processes that are running. Here you can see my process add.out, and then in another tab, I want to do something, which is this command, virtual memory map add.out pipeless. Okay, here we are. Now, with this very fancy command, I can see the layout of the process. So you see here, I have the process add.out, some other details here. Here I have virtual memory map of process with the specific number, which is the process ID. This is low-level stuff, you don't have to know. This space is 4096 bytes. So the operating system has given to this process this space, this number of bytes in memory. Then I have all these strange details that now we're gonna understand better. Here, as you can see, I have the addresses in hexadecimal of this space in memory. And now you're gonna understand what the heck we are doing. Do you remember before when I launched the program, I got this output, which is, where is hello literal? Is in this address. Now we're gonna find in our virtual memory map, where is this address, which is 105.69 for F. So look at here, 105.69, 1000. So I'm interested in this 1000. 105.69, 5000. Here I have 4F30. My hello literal is stocked inside this range, right? Do you understand? You see, this region type is exactly the text region I showed you before. It is exactly the region at the bottom. But what is the important thing here? You see, I have this region, and here I have the permission of this region. I have read, not write, and execute. I don't know exactly why the compiler has decided to put the string in this region. Later we will check on Stack Overflow, there is a good answer to this question, but never mind. The really important part is that I cannot write. You see, I don't have the permission to write in this special region, in this special range. This is the thing I care. So my string literal is in a place in which I cannot write. I cannot modify that string. Perfect. Now, where is the pointer to hello? So where is the pointer by which I can reach this unwritable region? It is in this address 7FFEEA56. Immediately understand that this is a big number, so I'm in the stack region. You see my image. The stack is at the very top of my virtual memory process layout, right? Is it at the top? And the stack goes from up to down. So when we make a program, it goes from up to down, 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 and not the opposite. So the stack is not growing, but it is decreasing. It is the heap that is growing, but never mind, this is a detail. So I'm gonna search for this address. Here, as you can see, I have the not writable region for this process. Indeed, I have my string, which is in this region here. I repeat to you, and then I'm gonna search from the writable region. Here, as you can see, I have the writable regions for this process. Then I go down, 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 down. What do you see here? Look carefully. I have the stack with this address. So as you can see here, I have the bottom of my stack and the top of my stack. Indeed, the address of the pointer pointing to the string literal hello, it's almost at the top of my stack. You see, this is in hexadecimal, but it is easy to understand. The numbers are equal till the 6, then I have E9, C8, and here I have F000. Of course, E is less than F, so you understand that my pointer is almost beneath the top of my stack. Then I have my array, which is A9C2. So it is beneath the pointer. And Of course, it is in this range, namely inside the stack, right? All right, this is low-level details, but I think it's sometimes useful to go deep and try to understand really what is going on. So the really important part of the stack is that we are in a region that is writable. You see here, I can read and write. Let me zoom a little bit. Here it comes. I have read and write permission in my stack. That's why I can modify my array. Let's watch again my very stupid slide. As you can see, my array lives in an area, which is the stack, where all the action takes place, in which I can read and write. Perfect. On the contrary, I have my hello string literal, which is in a portion of my virtual memory map, in which I cannot write. Namely, this is a read-only portion of this memory. This stuff is made by the operating system. I suggest to you, if you want to understand better, hold this story to watch some video. Maybe I'll give you some link, because this is a very shallow overview of what is going on, but you have nonetheless the biggest principle that I think you have to understand. Now you know why you cannot change chars of a pointer string, right? Perfect. So now you totally understand. If I have something like, if I want to make this program work correctly, I just need to change the string in an array string, so I know that this data structure is inside my stack, namely a place in my virtual memory map that I can change, in which I can write. So my string in position 2 equal to the char k is totally legal. Let's run this code. As you can see, I have my string that has changed. I have in position number 2 my k. This is totally legal. Perfect. Now I want to show you one last detail that I wasn't quite understanding. You see here I've declared a string array with the value hello. When you do something like that, you initialize an array. Meanwhile, when you do something like that, like this, you're gonna assign a value to an array. This operation is legal with arrays. Meanwhile, this operation is not. Let's try indeed to run the code with the assignment, and let's try to understand what is going on. So you see I have an error. Definition of variable with array type needs an explicit size or an initializer. You see? So let's give this array a size, for example 100, and rerun the program. It is not okay as well, because I cannot assign a value to an array. This is bizarre, because I can do, on the contrary, do something like that, right? I can do this operation. Now this is totally legal, because I have initialized my array and not assigned a value. So this is kind of, again, tricky, murky area of the C programming language. Basically here, what is going to happen? You know now that string literals end up in a memory space, which is read-only, right? You saw before that hello went in the text area, which is a read-only, again, space of my virtual memory process map. This data structure is an array in my main function. So what is happening here underneath the surface is that we have a string copy function. Basically, every char is copied inside my array. This is done by the compiler. And this is the process of initialization of an array. When I am here, on the contrary, and I try to do the same thing, basically I'm saying, please, this string literal, which is a pointer to a portion of my virtual memory map, you now understand perfectly well, assign this pointer to this s, okay? This is illegal because it's like saying, please change the pointer of my array with the pointer of the string. I cannot do that. This is tricky because you know that the name of arrays, the k into pointers, right, to the first element. But the name of the array, it is not a pointer. So in this case, it doesn't make any sense to change the pointer of the array with a pointer of a string. I cannot change the pointer of the array, otherwise I'm gonna lose this data structure. Basically, long story short, you can consider a name of an array as a constant pointer. That's why this operation is not legal. Okay, we have finished with this video. I'm gonna show you just one last thing. Here I am on Stack Overflow, and here's the question. String literal data type storage. Where these hello world end up, because it can end into text or in data. Basically, the rule is that the string is stored in data, but this is completely compiler executable format and platform dependent, so it can be stored in data or in text. Your string basically is in text where you have your code, or in data where you have your static global variables. These are details, of course, not very important for your goals. The main idea is that these two sections are read-only. That's why your pointer string is not modifiable. All right, perfect.